Hi, in this video, I will be showing you problem number 15 of chapter 8, section 1. Find the exact length of the curve y equal to ln of secant x lies between 0 and pi by 4. As in the previous problem, we have two formulas to find the length of the curve. L equal to integral a to b square root of 1 plus dy by dx the whole square dx. Whenever y is given as a function of x and x lies between a and b. The other formula is integral c to d integral square root of 1 plus dx over dy the whole square dy, where x is a function of y and y lies between c and d. Now you are given y as a function of x, y is a function of x, so we have to use, and also you are given bounds for x lies between 0 to pi by 4, x lies between a and b. So we are going to use the first formula, integral a to b square root of 1 plus dy by dx the whole square dx for this problem. So let's find out first, given y, which is ln of secant x, we're going to find out dy by dx, which is the outer derivative, which is 1 over secant x, times derivative of secant x, which is secant x tan x, which is the inner derivative. So this part is the outer derivative 1 over secant x, and the 1 in parenthesis is the inner derivative. So here we notice secant x cancelling out, so we just have tan x here. So dy by dx is tan x. Now we are going to find out what this value inside this radical is, which is 1 plus dy by dx the whole square, which will be 1 plus, from the previous step, tan x the whole square or tan square x. But by Pythagorean identity, it is secant square x. So now we are going to use the formula L, which is equal to integral the bounds for x. In this case, the bounds for x are given as 0 to pi by 4. So 0 through pi by 4. Then square root of 1 plus dy by dx the whole square, which we found in the step secant square x, so square root of secant square x dx. So it is integral 0 through pi by 4, square root of secant square x, even though it is absolute secant x, but we are only looking at between 0 and pi by 4, so in the first quadrant all trig values are positive, so there is no need for us to write the absolute sign. So it is integral of secant x dx. So integral of secant x is ln of secant x plus tan x. This is done between 0 and pi by 4. So we have to plug in the upper limit for ln of secant x plus tan x, which is the value pi by 4, and then evaluate the same expression at 0 and subtract. So it is ln of secant of pi by 4, which will be reciprocal of cosine pi by 4, so which will be just radical 2, then tan pi by 4, which is equal to 1. So that will be the upper limit, value of this expression at the upper limit. Lower is secant 0 plus tan 0. Tan 0 is 0, secant 0 is 1. So we have ln of root 2 plus 1 minus of ln 1, but ln 1 is 0, so we get that to be ln of root 2 plus 1. That is the length of the curve. So here, whenever you find the exact length of the curve, keep in mind you have two formulas, and you would use the first formula when y is explicitly given as a function of x and you know the bounds for x. You would use the second formula whenever x is a function of y and you know the bounds for y. Hope this video helps.